Genique. So today, I am here to give you some of the important topics of ISRO 2020, and here we will solve some important concepts of ISRO 2020 networks papers. Okay, so that it will be helpful for you for the ISRO and as well as GATE examination. Okay, so because we don't have much time and we people also have much time to give you the information regarding this networks, okay, and regarding this ISRO also. Okay, so that's why already if you search for the crash course networks, so there are so many videos are given by the Pankaj Shukla sir. Okay, he has given an excellent information in the network analysis. But here today I am here to give you a good concepts of the ISRO 2020 examinations for which is useful for the ISRO 2020 examination and also GATE examination also. Okay, just we will try to improve your knowledge. Okay, so come to this question. It is asked in the 2018 ISRO examination. Okay, it is asked in the 2018 examination. Okay, so see this question. So in this question, he is asked to find the current I2. Okay, find the current I2 in the network. Find the current I2 in the network. Okay, so where is I2? Here the I2 is present here. So this is the I2. So we have to find the current in this branch. Okay, in this branch. See this question, observe this. So this is a very good conceptual question. Observe this question. See, so how can you solve this current? How can you solve this? How can you find this current I2? See how many sources are there here? Here the number of sources are 1, 2, 3. 3 sources are there. Here is one source, second source and the third source. So because these 3 sources are acting at a time, okay, so due to these 3 sources, we have to find the current I2, right? So you know the superposition principle. If there are number of sources, if the number of sources are acting in a circuit, so to find the response in any branch, so we have to take the individual sum of the responses, okay, due to the each and every source. So here we have to use the superposition theorem, or otherwise you can also use the nodal analysis also. Okay, you can use the nodal analysis also, and you can also use the mesh analysis also. You can use any of these methods. You can use any of this method, but you have to choose a very effective method. So because a time limit is there in the examination, so that's why you have to go for the effective method. Okay, see, observe this question. It may be looking simple, but it has a good information to know. Okay, so come to this question. Here the question is, here a 4 volts is there. So with this 4 volts, a 4 ohm resistor is connected. Okay, this 4 ohm resistor is connected. So whenever we are finding the responses in the load side, whenever you are finding the responses in the load side, you can remove this 4 ohm resistor. You can remove this 4 ohm resistor. Okay, so that's why what? It is 4 volts is appearing across the 4 ohm resistor. So that's why we can remove this 4 ohm resistor. This is the thing you have to understand. Suppose if there is any resistance, is in parallel with the voltage source, if there is any resistance is parallel with the voltage source, okay, for the load current or load voltage calculations, for the load side current or voltage calculations, you can remove this R at the source. So that's why it is equivalent to this, right or not? So this is the thing you have to observe. Okay, so now, so how can you solve this question now? So now this 4 volts is appeared here. So you can remove this 4 ohm resistor, right? You can remove this 4 ohm resistor. Now what is the next? So this is 4 volts is appearing across this. See, don't remove this because a 4 ohm resistor is there here. Because a 4 ohm resistor is there, so that's why focus on this. So you cannot remove this. Okay, you cannot remove this. See, in this question, suppose if one more resistor is placed here, you cannot remove this. You cannot remove this. Okay, so this resistance will be placed like that only. Right? So this is the 4 volts is appearing now. Now apply the superposition principle. So if you apply the superposition principle, let us suppose 4 volts is acting. Okay, so I won't use the nodal analysis here because we have to solve, we will get the more number of equations here. So solving more number of equations may take very much time. Okay, so that's why I am not using the nodal analysis here. I am taking the superposition theorem. Okay, suppose if the 4 volt source is acting alone. Okay, 4 volt source acting alone. If the 4 volt source is acting alone, what about the next other sources? Okay, next other sources will be deactivated. Deactivated means what? What is deactivated? Deactivated means the current source is open circuited and the voltage source is short circuited. Okay, the current source is open circuited and the voltage source is short circuited. This is the thing you have to understand. So while applying the superposition principle, we have to take one source acting alone and remaining other sources must be deactivated. Okay, deactivated means what? The voltage source must be short circuited and the current source must be open circuited. This is the point you have to understand. So if you do this thing, then what is the equivalent circuit? So here you will get a 4 volts source is connected like this, 4 ohm resistor, it is a 4 ohm resistor. It's a 4 ohm resistor. Next, this will be deactivated. So this will be deactivated, open circuited. Okay. Now there is one resistor. It is a 1 ohm resistor, and this will be short circuited. These 2 volts will be short circuited. Okay. This 2 volt source will be short circuited. This is 1 ohm. Okay. These 2 volts will be short circuited, and what is the remaining? It is 2 ohm. Okay. So this is short circuited, and we have to find the I2 dash. I am taking this one as I2 dash because in the original circuit it is I2. Now I am taking this one as I2 dash because I have done some modification here. I am naming this one as I2 dash. Okay. So now what will be the I2 dash now? See, if you observe this circuit clearly, okay, this is 4 volts, this is 4 ohms, 1 ohm, 2 ohms. Okay. If you observe this clearly, this is only the source acting on this. Okay, this is the only source acting on this. See, if you observe this, this is a 1 ohm resistor, 1 ohm resistor, a 1 ohm resistor, 1 ohm resistor. Now, I am writing this one as, see, observe this. I am writing this one as here it is a 4 ohm resistor and here is a 4 ohm resistor. Okay, after that it must be This is the thing. It is a 1 ohm. 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 So in between these two, okay, there is a 2 ohm resistor is present. In between these two, there is a 2 ohm resistor is presenting. Okay, just I have drawn in the form of a bridge. Okay, I have drawn this circuit in the form of a bridge. See, this is a 4 volt resistor. It's 4 volt source. It is a 4 ohm resistor. It is a 4 ohm resistor. Right? So it is a 2 ohm resistor. It is a 2 ohm resistor. If you observe this, see, observe this. These are the 4 volt resistor, 4 ohm, 4 volts source, 4 ohm resistor, 4 ohm resistor. Next, open circuited here. Here is the open circuited. Next, there are 2 branches like this. There are 2 branches, means 1 ohm, 1 ohm. Next, in between these two, there is a 2 ohm resistor. And next, these two are connected like this. And this node is connected to this. And this node is connected to this. Okay, it's a perfect bridge. So what will be the current in this? So we have to find the I2 dash. Okay, we have to find I2 dash. So here is the I2 dash. So because the bridge is balanced, so what will be the I2 dash? The I2 dash will be 0. This is the thing we have to observe. Okay, I2 dash will be 0 because let us suppose this is R1, R2, R3, R4. Okay, R1, R3 is equals to R1, R4 is equals to R2, R3. These opposite resistances, okay, opposite branches are having the equal magnitude. So that's why we can say that the current through this diagonal element will be 0. Okay, so that's why this is 0. So this will be I2 will be 0. I2 dash will be 0. This is the first point. Now similarly, observe this. If the 4 volt source is acting, we got the I2 dash is 0. Now next one is what? Next one is 1 ampere source. Let us suppose if 1 ampere source is acting. Let us suppose if 1 ampere source is acting, then what will be the I2 dash? Okay, I2. Now suppose I am writing 1 ampere source is acting. Okay, now I am writing 1 ampere source is acting. See, I am writing here I2 dash here. I2 dash 0 we got. This is the first result. Okay, now 1 ampere source is acting alone. If 1 ampere source is acting alone, then what will be this? This will be 1 ampere source. It is 1 ampere source. If 1 ampere source is acting alone, remaining other are deactivated. This is one source, this is one source. This will be short circuited. So that's why it is short circuited. Now what is this? This is also be short circuited. Okay, this is also be short circuited. So this is the thing. Okay, so this is short circuited. Now what happens? Only this is the circuit is acting. Now observe this. Here also, if you observe it clearly, what is this? 4 is parallel with 4. Observe this. If the current is coming like this, this 4 is divided in this. The 1 ampere. Let us suppose some I amount of current is coming like this. The I is divided into I by 2. Here it is I by 2. So I can remove this 4 ohms and 4 ohms, and I can put this as 2 ohms. I can put this as 2 ohms because these two are parallel. Okay, leave this. So after having this, what can I write? After having this, what can I write? I can write this one as 1 resistor in parallel with 1 ampere current source. Okay. Now, if you observe this, so this one source is acting. Again, you have to find the current in this branch. So I am naming this one as I2 double dash. Now again this is the bridge is balanced. Same you are getting this. So if the bridge is balanced now, here also what you will get? Here I2 double dash will be 0. So this is the second thing. So I2 double dash will be 0. Now come to the third one. So what is the third one? The third one is this. If you write the third one, if the 2-volt source is acting alone, if the 2-volt source is acting alone, now what will be the circuit? Now what will be the circuit? This is the original circuit. Already whatever may be the source is acting, this 4 volts will not be, this 4 ohms will not be there. So this is the circuit, right? Now if the 2-volt source is acting, if this is the source is acting, now come to this. What happens? This 1 ampere will be disappeared, means open circuited. Okay, this 1 ampere will be open circuited. Now come to this. Okay, this 1 ampere is open circuited and this 4 ohms will be presenting, and here observe this, and here you will get a 4 volt, and this 4 volts is also like this. This is the 4 ohms, and this is short circuited. Now what happens here? Here it will be there. Okay, it is minus plus, it is 2 volts, right? So this is the thing. When the 2-volt source is acting, this must be kept here, this must be kept here, and remaining all the sources will be deactivated. Now observe this. How can you get the answer for this? Now I am naming this one as I2 triple dash. How can we get the answer from this? Okay. Similarly, observe this. I will get the same kind of bridge here. So, but in this bridge, what it will be? In this bridge, already this is short circuited. So that's why this is short circuited. If this is short circuited, what happens? These 4 ohms and 4 ohms are becoming what? 2 ohms. Okay, they will be connected parallelly to this. It is a 2 ohm. Okay, anyhow this is open circuited, so no need to write here. So you are again having 1 ohm, but in between these two nodes you are having a 2-volt source. Observe this, a 2-volt source and 1 ohm resistor. Okay, it is a 2 ohms. It is a 2 ohm resistor and 2-volt source, right? It's a 2-volt source. Now what will be the current I3 dash, I2 triple dash? I am naming this one as I2 triple dash, right? So this is the current I2 triple dash. So what will be the current in this? Okay, so from this, so when 2-volt source is acting, so this is the equivalent circuit, because this 4 ohm is parallel connection. So this 4 ohm will become 2 ohm. Now this is the equivalent circuit. Now if you observe this, here is the source. So this is the diagonal element. Okay, so if you observe this, if the source is, see, I can also write like this. Observe this. If this is the source, what is the remaining diagonal? In this remaining diagonal, the current will be 0. See, the above circuit I am writing here. Observe this. The above circuit I am writing here like this. I am writing the above circuit like this. I am writing this 2 ohm resistor. I am writing this 2 ohm resistor like this, and this is 1 ohm, and this is 1 ohm, 1 ohm, 1 ohm. I am writing this 1 ohm, 1 ohm, 1 ohm, 1 ohm like this. I am putting this 2 ohm resistor in between. Now I am taking this. I am taking this branch outside to this. So it is just like what? It is just like, it is 2 ohm, right? It is just like 2 ohm, right? So now what is the current? This is the current, I2 triple dash. I2 triple dash we have to find, right? So this is the current. Now what will be the current now? What will be the current? See, because the bridge is balanced, now there will not be any current flow in this. So I can remove this element because the I will be 0 in this. There is no current flow because the bridge is balanced. In the diagonal element there will not be any current flow. Now this is the current. So the current is from this point to this point. Now what will be the current? See, if you observe this, if this branch is open circuited, now what happens? What is the current is coming like this? Okay, it will be divided in this direction and in this direction. Okay, it will come in this direction, and it will come in this direction, and again you will get I2 double dash triple dash, right? This is what? The same current is flowing because there is no current in this path. So the current is, how much current is flowing? This is I2 triple dash divided by 2 will come like this. I2 triple dash divided by 2 will come like this. So this is what? These two are in series now. These two are in series now, right? These two are in series and these two are in series. If these two are in series, this is a 2 ohm and 2 ohm. 2 ohm parallel with 2 ohm. 1 ohm. Okay, 2 ohm parallel with 2 ohm. This is 1 ohm. Okay, it is 2 volts, right? So the final answer will be how much? The final answer will be, it is equivalent to, how can I write? This is, it is 2 ohm. The parallel combination is 1 ohm. It is totally 3 ohm. Okay, it is totally 3 ohm. So now I am writing this one as what? I2 triple dash. So this is minus plus 2 volts. Okay. Now what is I2 triple dash? I2 triple dash is equals to, I2 triple dash is equals to, this is 2 divided by 3. In this direction, right? It is 2 divided by 3. It is 2 volts. 2 divided by 3. Okay. I2 triple dash is equals to 2 divided by 3 amperes. Okay. So this is how much you got? I got I2 triple dash is equals to 2 divided by 3. This is 3. Now what is the total current? The total current will be I2 is equals to I1 dash plus, sorry, I2 dash plus, I2 double dash plus, I2 triple dash. This will be 0 plus 2 by 3. This is, answer is 2 by 3 amperes. Right? The option A is the correct answer. See, this much of calculation we needed. Okay, so from this what we can say? We can say that this entire portion is a redundant network. Just to make you engage in the time, he has given this much of network. Okay, so this is entire thing is a redundant network. Only because of this you will get the current in this. So remaining the entire thing is a redundant network. So observe this, because these all are outside the network. But if you clearly observe this, this is already balanced. Okay, 1 into 1. So observe this network. So it is just like whenever you see this, you should assume one network. Whenever if you see this kind of network, you have to connect this with the network. Okay, so definitely you should get some kind of bridge in your mind. So then only it will be easy for you. So this entire thing is a redundant thing. So you have to focus on this. 1 into 1 is equals to 1 into 1. So that's why it is looking like a bridge. Okay, so whatever may be if you connect 10 number of sources also, left side to this, there will not be any effect for this. Okay, that is the thing you have to focus. These kind of questions will be asked in the examination. So definitely you will get the questions on the bridges. Okay, so like this. I hope you got it.